Gophers from Russia. I'm Rashmi Nagpal and I'm currently interning at LoopUp. I'm not a native Russian speaker, but I try to learn a couple of words. So, if I'm incomprehensible or if I fumble in between, then I do really apologize. And I'm so excited to present you some unsung gotchas in Go. Let's begin on this journey together. The very first gotcha highlights that the range iterator returns two values. A very early trap for the beginners is that for range in Go works a bit differently than its equivalents in other languages. It returns one or two values. The first of those is an iteration index. That is, it could be a map key if a map is iterated upon, and the second is the value. So, if only one variable is used, then it's an index. The next gotcha states that the defer doesn't work for code blocks, only for the whole function. In this example, a deferred function call will be added to the list when I is 0, 2, 4, 6, and 8. But it will only get invoked when the main function exits and not at the end of the if statement. And the next gotcha makes us ponder that shouldn't it be the different addresses for the different zero size variable? Let's see. If you have two different variables, shouldn't they have the different addresses? That's a very interesting question, isn't it? Well, it's not the case with Go. If you have zero sized variables, they might share the exact same address in memory. The next gotcha revolves around that for iterating through map using for range. That's quite an interesting because every map iteration will produce a different result. WaitGroup allows the goroutines to cleanly exit before exiting the main program. So let's see a gotcha which revolves around this. The rookie mistake will be that the app will not wait for all your goroutines to complete. And one of the most common solution is to use the WaitGroup variable. It will allow the main goroutine to wait until all the worker goroutines are done. And therefore you can see all the goroutines are done and the output is what we desire for is printed here. This gotcha is based on the read and the write operations reordering. Go may reorder some operations, but it ensures that the overall behavior in the Go routine where it happens doesn't change. However, it doesn't guarantee the order of execution across multiple Go routines. And if you run this code a few times, you might see that the apple and the banana variable combinations will be different. And the most interesting combination which I found was of 0 and 2, which signifies that the banana variable was updated before. So, if you need to preserve the order of the read and the write operations across multiple Go routines, then you will need to use channels or the appropriate constructs from the sync package. This gotcha is about unmarshalling the JSON numbers into interface values. By default, Go treats the numeric values in JSON as float 64 numbers when you decode or unmarshal JSON into an interface. That means this code snippet will fail with a panic. If the JSON value that you are trying to decode is an integer, then you have several options. The option 1 is to use the float value as it is. Option 2 could be converting the float value to the integer type as you need. And the option 3 could be using a decoder type to unmarshal JSON and tell it to represent the JSON numbers using the number interface type. The next one, gotcha, is on recovering from panic. The recover function can be used to catch or intercept a panic. Calling recover will do the trick only when it's done in a default function. And here is the correct version. So this gotcha is on map, while a slice type is a struct or a value type that has a pointer to an array. And the zero value of a slice is already fully usable. You can always use append to add elements and get the slice's length, while a map is different. And the Go developers would like to make map zero values fully usable. But to implement that efficiently, it's still a mystery. The map keyword in Go is an alias for star runtime.hmap type, and its zero value is null, and the null maps can be read from because map items are accessed with functions. And let's see through an example a tricky gotcha using a map. Here inside the main function, as you can see that printing the length of the map is okay since it will print 0, and the next line reading the null map is also okay as it will again print 0. But the last line during the assignment operator, it will panic because it's an assignment to null map. So let's see how we can fix this one. When a pointer to a map is passed to a function, the value of the pointer is copied because in Go, everything is passed by value, including the pointers itself. The next example or the gotcha is on data race conditions. The map access is unsafe only when updates are occurring. As long as all goroutines are only reading or looking up the elements in the map, including iterating through it, using a for range loop, and not changing the map by assigning two elements or doing deletions, it is safe for them to access the map concurrently without synchronization. The access to the map must be synchronized through sync.mutex or sync.rwmutex or some other memory barrier, or coordinated with Go channels to prevent the concurrent access, as you can see in this code snippet here. The next gotcha is for loop iterators can be reused in Go routine. In loops, the same iterator variable is reused for every iteration. If you take its address, it will be the same address each time. That means the value of the iterator variable, here it's an I, gets copied over to the same memory location on every iteration, and it makes loops more efficient but it's also one of the most common traps in Go. So let's see how we can fix this one. The, these coroutines are created in the loop, but it takes a lot of time for them to start running. Since they capture the single I variable and println prints whatever value it has at the time goroutine is executed. In this case, you might create a new variable inside the code block, as we saw in the previous slide, or you can pass the iterator variable as a parameter to goroutine. So let's see a next gotcha through defer. And the defer statement pushes the function call onto a list, and the defer calls are executed in LIFO manner, which is last in, first out. A deferred function's arguments are evaluated when the defer statement is evaluated. The list of the saved calls is executed after the surrounding function returns. And also, defer is commonly used to simplify functions that perform various cleanups. In this example, you can see that the expression key is evaluated when the println call is deferred, and the defer call will print 0 after the function returns. So, if we go next, we can see in the sample function that the deferred function increments the return value key after the surrounding function returns. Therefore, this function returns key 1. The next gotcha is based on the encoding and the Go package. There are the list of the things about the Go's encoding and the JSON package which might surprise you. So let's understand the first of them, that not to use more while checking for remaining JSON objects in a stream. When processing a stream of the JSON objects with JSON.decoder, don't use the more method to check if there is a remaining object in the stream. Despite its name, more is also not designed for this purpose, as it can also cause some subtle problems. And the more method is intended to be used in conjunction with token, and it exists specifically to check if there are is or if there is in any other element in the array or the object being currently passed. For example, if you use it when decoding an invalid JSON stream like the fruit apple fruit banana, notice the additional square bracket at the end. It won't result in an error, while it should be. That's quite strange, isn't it? Let's see how we can fix this one. The correct technique to see if a string contains another JSON object is to check for an io.eof error, which will be returned when there are no more objects to process in the stream. And voila, we got what we desire for. The next example is in struct tags, non-ASCII punctuation characters aren't supported. Any struct tags containing non-ASCII punctuation characters will be ignored when decoding values from a JSON object into a struct, and the struct field will be left with its 0 value. For example, in this code snippet, we see that the output of the cost EUR is blank. This can be annoying in the situations where you need to decode a JSON object, but it has keys which are non-ASCII characters. And you can't change the JSON. So there needs to be a fix around this limitation. And let's see how we can do that. You can decode to a map as an intermediary step and then copy the data from the map to the struct. And that gives you what we desire for it. Go follows a model of the concurrency called the forejoin model. That means that our program can split into its own execution branch to run concurrently with its main branch. At some point in the future, the two branches of the execution will be joined together again. Also, we have the WaitGroup mechanism, which fires off the concurrent operations and let them do their work and then wait for them to finish. Through this example, let's understand where the gotcha lies. Here is our string slice with the Greek philosophers that will be print concurrently. And we have also declared a wait group WG. For each element in the Greek slice, we make a call to wg.add1. Basically, wg.add function adds to the wait group counter using an anonymous function in the range loop. And the output of the program is following. That firstly, it prints let's start, then it prints Democritus 6 times, and lastly it prints we have reached towards the end. That's quite strange. That's not what we desire for. We need a fix for that. Let's see how we can fix it. We need to pass a copy of the ph to our anonymous function and thus make sure that the coroutine will work on the data from the iteration of the loop. Since from the previous slide, one can always introspect that there is a high probability that the loop may exit before the coroutine begins. And therefore, the variable ph may fall out of the scope. And it needs to grab the last reference of that which are on the heap so that the coroutine can continue to access it. That's our final gotcha. Deadlocks. Based on deadlocks. A deadlock manifests itself when a program with concurrent processes are waiting one another. In this state, the program will never recover, while the Go compiler will notice this error on the compile time and will give us a warning, and also it will refuse to compile the program, as you can also see in this output. So we need to unblock it, and let's see how we can do that. So to unblock the send operation from another coroutine, we can do the send operation in a separate coroutine that will unblock at the element 3. But because the receive operation executes in another coroutine, the code will unblock. These are the couple of resources for further reference and in order to delve deeper. As we see in Russian, Spasiba. Thank you so much. And the floor is open for questions. Thank you so much.
So how do you find Go overall compared, what you expected? Maybe like how you compare yourself like on the first week of Go and like now?
Sure, that's a very interesting question. So when I started, I was quite, surprised because there are some things which are very common in other languages while not in here. So I always get to stuck in something or the other. Then I have to Google stuff. But now I have to realize, like after years of like experience and then working in making like some small side projects and learning and being with the community and asking your doubts, it has helped me a lot. And therefore I just wanted like to people also to understand how from a beginner's perspective to the person who is new in this language as well, with 2 years of 2-3 years of experience, still feels there are some gotchas and would really love the other developers to learn and share their own bits and pieces.
Okay, so if there was one thing you can change in Go to make it easier for you and for other people who are new to Go, what would it be?
That's quite tricky. Yeah, I mean, having a collaborative environment and then asking your doubts and removing some of the pointers which are still there are there, and map function. Some of the functionalities, but I still feel Go is I mean, it's like a small baby of the programming language which is flourishing over the period of time. It's not and there are certain other functionalities which we feel from other languages should be incorporated in this language. But again, it's unique in its own sense. It has the concurrency, which is the principle, and so I think yeah.
Okay. We have a question. What gotcha was the most unexpected for you? Which one?
When there is a map, which was like a reference, so that was like, I always thought like from other programming, it's a pointer, but still it's an open-ended question right now. So I really felt that it was unexpected for me, that question. And so I really loved one of that gochas. And of course the deadlocks and the concurrency, which I always feel that are stuck still. So bunch of concurrency examples are also like good gochas.
Okay, thank you. No more questions yet? Okay, then thank you.